All right, with that, we'll keep moving. Thanks very much, Tom. Next up is Dan King from the Iowa Ready Mix Concrete Association, who is going to tell us about how well these things do in real life. Dan, take it away.
All right, thanks, Peter. Good thing about being the last one to go in the session is some of the material I have here has definitely already been covered today, so we can go ahead and get moving. This presentation is going to be about the field performance of concrete overlays here in the United States. As Peter alluded to earlier, we've been building these now for more than just a couple of decades, and even though it is a relatively new concept in a lot of places and a lot of states are just getting into it for the first time, there's a lot that we can still learn from what's been out there. And so I'm going to talk a little bit about kind of the background and history of that, and then touch on some of the states out there that have done some performance studies and looked at what their history is with concrete paving, how well they've done over time, what kind of service life they're getting, and the things that we can learn from that, and then use those to improve design and construction moving forward, kind of the whole reason we're doing these things. So with that, concrete overlays, again, they are still a relatively new thing in the world of pavements, but there's something that engineers have been thinking about for a long time. I really like the sketch, the concrete paving engineer for the Iowa DOT found this a couple of years ago. It was plans for a concrete overlay that were put together all the way back in 1949. And I actually don't know if we figured out if they ever built it, but you can see the engineers there at the Iowa DOT were, trying to think of something new or turning it over in their head. And it was probably there were experimental projects built over time. It was probably about the 1970s and 80s. At least I know that's the case in Iowa, which is one of the states that kind of was a relatively early adopter of concrete overlays. That was when they started, putting them into practice relatively more often. That's a famous in our world project on an airport runway in Storm Lake, Iowa. That was one of the first major concrete overlays of asphalt here that kind of helped kick off a lot of concrete overlay construction. And then kind of moving from there, from the 1990s on, you've seen more states adopt concrete overlays. There have been a lot of innovations in design, some of the thinner bonded overlays that we've talked about earlier today, different materials like we just saw about fiber reinforced concrete, for example. But concrete overlay construction has been moving forward. And, you can see here, especially since about 2000, and especially in the last 10 years, you've had a pretty substantial increase in, this is the bar graph here is overlays as a percentage of all concrete paving. They've gone from a pretty small niche thing that was, done here and there to, being a pretty regular part of the pavement system. And depending on what state you're in, like in Iowa, being from Iowa, for example, we actually usually here it's something like 20-25% of our concrete paving every year are concrete overlays. So in some places, they've definitely become a regular part of the system. This map here, you can see the Midwest has been a pretty big adopter of overlays. Iowa, Illinois, and we'll talk about, again, some of these states have been building them for a while, but not to leave out, we've had a lot of overlays built in some other states like Colorado, Oklahoma, Pennsylvania, and that's only been increasing over time. So we've been seeing more and more, they're beginning to spread. And, like I mentioned, they are new in some areas, but I think Peter already used the same metaphor. But in other places, they're one of the tools in the toolbox that pavement engineers have. So we are seeing more and more of them, especially as agencies maybe gain some experience and, start to implement best practices and things like that. They're definitely something that can become a successful regular part of the pavement network and that engineers can use to evaluate, candidate projects and things like that. So with all of that, it's great that we see more and more concrete overlays, but especially, whether you're a state that's just getting started with them or maybe a state that has been using them for a little while but are considering, do I want to continue using concrete overlays? Do I want to, am I doing things the right way? Do I want to make adjustments? It's important that we look back to figure out how these pavements that we've built in the field have actually performed. We want to know what kind of performance life and service life that we can expect from these types of projects. And again, what is working, what's not working. You have pictures of two pavements here. One of them was quite a bit older than the other, but that one performed a lot better than the pavement that was younger. So, what are those design practices, design methods, all those things that go into evaluating and then designing and building concrete overlays. There are a lot of lessons we can take away by looking back at performance, and I'll actually come back to that project pictured there on the right because that turns out to be something that was pretty significant that we've used to improve our practices going forward. So we have had a lot of good case studies of individual projects that have been done over the years. That report that I have pictured there in the bottom right, that's from the CP Tech Center from 2014, where they went and looked at some pavements all around the country and wrote up some case studies, which is great. What we haven't had as much of, just kind of in general, since concrete overlays are relatively new technology, just, for the whole pavement realm, is, really comprehensive reviews and analysis of large data sets. There haven't been as many instances of those, but we are starting to see some now. So I am going to show some examples of what we have there in this presentation. And, part of the limiting factor for that is, concrete overlays are relatively new and technology has been changing. So, we've only been building some of these, we've only been building concrete overlays with some of these things like short joint spacing, the 6 foot by 6 foot panels, again, with fiber reinforced concrete or the new geotextile interlayer. Again, all things that have been talked about in this session here today. A lot of these concepts have only been put into practice for about the last 10, 15 years. So sometimes we just have limited data. The best we can do is a case study. But as these projects begin to age, that photo in the middle there is from a project in Illinois that would have been, as far as I know, one of the first fiber reinforced pavements, kind of just built as a regular project, not as part of just a test strip or something like that. That project's 15 years old now, so we can start to learn more by evaluating performance. And again, they're becoming increasingly common. We have a lot more older projects now that we really can take away information. So we do have some examples now of some more comprehensive reports of performance, which we'll be going over here. So before we dive into that, I'll just, depending on what your background is in terms of if you work with pavements commonly, you're probably already very familiar with the types of performance data that's collected to assess pavement condition. But just for anyone who's not as familiar, all this data is usually collected by vans that have all sorts of instruments that are able to assess, the condition of the roadway. Some of the common metrics would be something like International Roughness Index, which is a way to measure ride quality. That's an extremely common one that you'll see in this presentation is that different states are looking at, and you'll see it referred to for all sorts of pavements, to define the pavement network all over the country. Obviously, you can, use this data to, count how, cracked slabs. You can measure faulting if a project has significant levels of faulting. Friction, you can do image analysis to try to tease out whether you've got joints falling, if it might be caused by materials related issues. Patching is kind of an interesting one sometimes to use to characterize pavement performance. But long story short is all of those come together, and usually you'll see agencies calculate something like an index. Just, try to put one number on a pavement to kind of characterize its overall condition, or maybe its remaining service life. So some of the terms you'll see used are like common one, or at least what we use in Iowa, is pavement condition index, or PCI, which is a 0 to a 100 scale, where 100 would be when the pavement was brand new, newly constructed up here. 0 would be, the pavement's completely fallen apart. Different agencies will have different indexes that run maybe on different scales. You may see it in terms of remaining service life, where they're trying to translate that condition index into something like we can expect we have 10 more years left in this pavement. There are examples of both of these types of indexes in the presentation here, but just if you aren't familiar with that, that's kind of a very normal tool. There's actually, I think Peter and Kurt both had examples in their presentations today, kind of showing what a usual condition curve looks like. And it usually is a shape, or at least the theoretical shape is something like this, where usually the pavement remains in excellent condition as it's newly constructed, and then over time it does start to deteriorate more and more, and then maybe reaches a terminal point where it's going to need to be replaced. And so or rehabilitate it, or evaluating lots of different rehab options, including concrete overlays. But obviously, we can use a curve like this to assess the performance of a concrete overlay itself, and we have lots of examples of that here. So, kind of get to what those performance studies have looked like for these projects in the U.S. I mentioned the CP Tech Center's report from a few years ago, which was very nice because it really does select projects that were built in all sorts of climates. You can see the examples of states there. So it covers all different areas of the country where you would have variation, not just in your climates, but materials that are used as well. Lots of different design contexts. You have divided highways like the road pictured here. You have some rural, urban, interstate sections, so all different types of traffic volumes. And case studies like this are always nice because you can get into a lot of detail about the performance of an individual project, but obviously the data set itself, if you're looking for just a large volume, like a big data type data set, you're not going to have as much there. So there's always a lot we can learn from studies like this, but we're also, again, as more and more projects are built, we do have the ability to do more, dig in a little bit more and do some data analysis with larger sets of performance data. Another thing that is out there, if you're plugged into the industry, especially if you work with concrete overlays a lot, there are a lot of states that are tracking performance in-house and putting together their own databases, and they may be using it to make decisions and things like that, but they're not necessarily published data. So I just wanted to show an example. This is from Colorado. They look at the performance of their projects in-house and they keep track of where they are, both the agencies and the industry there. Although I don't believe they've ever published any of this performance data that they have as a formal study. But you can see here they're tracking, where they're thin overlays of 6 inches or less. Commonly, those are bonded concrete overlays of asphalt. So they have a database where they know where all these projects are around the state. And they've tracked, they know how many millions of square yards it constitutes. They've divided it between different overlay types. Here they've divided by thickness in these examples. And, based on the data that they have in-house, they know that a lot of these projects have been able to fulfill a 20-year design life, and they still have some life remaining. They're using kind of one of those remaining service life type metrics here where they know they have about 8 to 10 years left in a lot of these pavements. So this type of information is great, but obviously if you're not, super plugged into industry, you don't always have access to this, or you might not know where to find it or who to ask for it. So one of the things that I wanted to make sure to, I thought it'd be good to be able to include in this presentation is kind of a summary of things that have been published, so that you can get a reference point and see things that have been distributed more widely, peer-reviewed, and things like that. So starting out, Illinois was kind of another one of those early adopter states for concrete overlays. In particular, at the time they were calling it ultra-thin white topping. This would be BCOA, as has been referred to during these sessions here. Again, those are those thin bonded concrete overlays of asphalt. But several years ago, a report was published kind of doing a survey. It was mostly a survey-driven study. There was some structural analysis of these pavements and crack surveys and things like that. It wasn't quite a lot of the same automated condition data as a lot of other studies, but it was a good sample size because Illinois probably was the earliest adopter at a relatively wide scale. You can see on that map there, that's just the BCOA projects in Illinois. So they have a nice set of projects to look at, some that have some age. So that was a good study there. And then also in recent years, they've published some performance assessment with kind of the normal pavement performance data of concrete overlays that have been built on the interstate system there. And some of those projects are quite a bit older. They go back, 20 plus years. I think one of the projects there is more than 30, but so they've done some of that type of assessment as well. For those ultra thin white topping or BCOA, again, thin bonded concrete overlays of asphalt, they found so far that a lot of those projects are on track for about a 15 to 20 year service life, which is probably, what the design life was intended at the time. And they've also found, some of those newer ideas and concepts that we have now, like the fiber reinforced concrete, that they do seem to improve performance of the system and help mitigate some of the distresses that were seen on some of the earlier projects that were built before those types of technologies were available. And I'll I do have some slides kind of summing up some of the things that we've learned from these studies later. So I'll have some examples on how fibers can help improve performance there. For their interstate system, they found some really nice long-term performance. Again, these are mostly thicker unbonded overlays, or at least especially those older projects. And that's the plot you see here, where they have again, they have an index here. The plot shows it running from between 4 and 9, but obviously the higher number is better. And you see performance of these pavements projected to, decline over time. They just have a linear fit here. But basically, they're showing about a 30-year projection to the point where it gets to be a poorly rated pavement for their thicker unbonded concrete overlays, some of which are CRCP overlays actually on the interstate system. So they're seeing some good, again, your design life context might be different. Thinner bonded overlays tend to be designed for, you're using them to maybe not have to get so many years out of them, but you can see that you can also design your concrete overlays to last a long time by using one of those thicker unbonded systems. So kind of good examples of both here. In Iowa, this is a study that we did a couple of years ago. You can see I repeated the map. Iowa really probably was the first state to really adopt concrete overlay construction at a wide scale. We have more projects here than any other state. The data we collected was through the year 2015, so it was over 500 projects at that time. And it's quite a few projects that have a lot of age. Almost 100 of those were actually built before 1990. So that at the time that this data was all captured, that's 100 projects that are all at least 25 years old. So a great data set to work with, a lot of information. And the market for concrete overlays in Iowa is mostly concentrated on the rural county highway system. So that's kind of the main, we do have examples of all types of overlays that were included in this study, some that were built on higher volume highways. We have, some that were built on the interstate, divided highways, city streets as well. But a lot of them are look like the one that's pictured here. This is very typical for what concrete overlay in Iowa on a, relatively low volume county road, maybe like 150, 200 trucks a day. And commonly, the common design here is something like a 6-inch thick overlay, which is probably right on the border between, if it was on asphalt, right on the border of what you would consider bonded and unbonded. Really, it's probably an unbonded system is what it's most related to. But anyway, again, we did this study a couple of years ago with the CP Tech Center. Very comprehensive data set with all different types of projects and older projects as well. And I won't dive into deeply into the results here because the report's long and has lots of good examples. So I would refer to that, but you can see that here for the set of projects that we have in Iowa, we had, again, some very nice long-term performance with just a simple linear trot in terms of our pavement condition index on a 0 to 100 scale. We were seeing about a 35-year service life to get to that fair condition, which is usually where local agencies here start. Well, DOT as well, but it's when agencies here kind of start evaluating rehab options. If you just put it in terms of IRI, again, IRI being a metric for ride quality, very similar story. Again, just with a simple linear plot, you're getting up to that 30 to 40 year range before you get to this threshold that FHWA uses to define, when ride quality starts to become unacceptable. And all the different types of projects, both those bonded and unbonded systems over concrete and asphalt, all performed well. Other than, bonded concrete on concrete, it's been mentioned earlier, isn't very common at the moment. And but the other types of systems that are, part of the regular practice today did well. And anyway, not to spend too much time on this one because I want to make sure we get through everything here. But you can go look at the report for some more of these results. And again, concrete overlays here, we see quite a few projects built every year on the county highway system. They seem to work really well in that type of context. And then kind of the last state that has, one of these comprehensive types of reports are our neighbors to the north in Minnesota. For quite a few years now, they've been building thicker unbonded concrete overlays as a long-term rehab solution. And then recently, they've also been adopting, overlays of asphalt or white topping as well. Some both, relatively thin and, maybe medium or thickness. So mostly bonded, though. They've looked at a lot of BCOA projects. And they've done a couple of studies recently. So just to share some of those results, their white topping projects, again, these tended to be on lower volume roads similar to Iowa county highways, and they've had good early performance from some of these projects. For a lot of them that have been built just within the last 9 or so years, they're projecting approximately a 20-year service life. One thing they found in some projects where they built these with heavy truck traffic, they did observe some early age faulting, so that was kind of one of their notable findings to keep in mind. For their thicker unbonded overlays, again, these have proved to be a great long-term solution, and they're projecting about a 35-year service life for their thicker unbonded overlays. And again, these reports are both available if you go to MnDOT's, you Google it, or if you go to MnDOT's research studies. Just a quick review of some things, not just graphs and charts and things like that, but all these studies have involved going out in the field to, see what some of those, if you see an outlier here or there, or even just to look at what a typical project looks like, it's always good to actually, do some investigation on things that might have gone wrong, or make sure you understand better, if things are going well, to know why things are going well. So just some of the unique findings that we've used to, try to improve both design and construction practices and ensure good performance going forward. Just want to definitely make sure to note everything that Tom talked about in his presentation earlier about, using good materials, using good mixed design practices. That's really important because you can have a perfectly well-designed overlay, but if you don't use, good materials, you're going to get early age failures. And that was actually in the Iowa study when we looked at those projects that didn't perform as well. That was the number one problem that we would find, was that it was a pavement kind of like the ones pictured here that have obvious materials related issues. I mentioned we would return to this project in Illinois that I showed that had you can see a lot of cracked slabs there at a relatively early age. And there were a lot of trucks that used this route. But what we have found over the years is that, one of the concept of using shorter slabs is that it can help reduce the stresses in your overlay, and that can be especially useful in a thin bonded concrete overlay of asphalt. But the problem is if you reduce the panel size all the way to 4 foot by 4 foot or so, such that those panels fall in the wheel path, and here there's another example pictured there from a project in Iowa, that ends up being a problem with just the way that the stresses are there kind of in the pavement system at the edge of the slab. So this is something, though, that we've been able to take, and moving forward, design procedures now, like if you've ever used the BCOA ME design procedure from the University of Pittsburgh, they use separate models now for those 4 foot by 4 foot panels to account for problems that can arise from those types of situations. So kind of coming out of this, if you're using a thin bonded overlay, 6 foot by 6 foot is now kind of the most common joint spacing for those types of projects. Sometimes we've seen things like joint misalignment and panels that seem to slide, and this mostly happens in thin bonded concrete overlays of asphalt. Sometimes we think it may lead to blow-ups, but something that we think we've found so far in the relatively short history that we've used fiber reinforced concrete is that might be one way to help mitigate this issue, where you might just have some panels, the joint opens up, and between maybe traffic stopping and starting or things like that you can cause these panels to come out of alignment. But fibers might help mitigate that. Filling joints, some projects joints would go unsealed, and that might not, it could be related to issues, maybe related to blowups too, but filling joints might be another solution that's working. It's something that these studies are kind of still digging into and that we're still looking at as an industry. We've looked at joint activation sometimes when we saw these short joint patterns into concrete overlays and end up with 6 by 6 panels. The initial stress buildup in the early age of the pavement might not actually be enough to activate all of these saw cut joints. And, it's possible that this might lead to dominant joint behavior over time, could be a factor into stresses. You might just have a system that's not performing the way it's designed. And so, should we do something maybe to adjust our design and construction practices to account for this? Something they've been doing in Minnesota within the last few years, or at least they've tried it out on a project here or there, is that when the pavement's been about 24 years old, 24 hours old, or about the time that they finished saw cutting. They've been running the water truck up and down the slab, and they've noticed that seems to cause more joints to initiate in, kind of that first several days. You can, just by looking at the edge of the slab there, they seem to think that's made a difference. So, and then, again, using fibers, the way that the fibers can kind of take on some tensile stresses, that may play a role in all of this, but something that industry is still looking into. And, CP Tech Center had a study kind of really digging into this a couple of years ago, if you want to learn more about that. But again, just documenting and demonstrating performance, it's going to be something that's really helpful, both for agencies that are brand new to concrete overlays and ones who, are continuing to build them, maybe look for different situations or expanding their use. Being able to refer back to performance studies like this will be important. And that's kind of basically answering the question, why is this worthwhile, or what are we doing it for? This is something that'll be really helpful going forward, and both to help agencies feel more confident adopting overlays, and also just in general improving the state of design and construction, as I mentioned here. And this is kind of the last maybe takeaway point, is that, this was when we did our Iowa study, we were just looking at subsets of the data. And one thing we noticed was that if all of this is, just a subset of certain projects, and all of the data points shown here are within the same subset. But if we looked specifically at the outlier projects, again, a lot of these were materials related to stresses, but, the gray trend line here is just the trend line for all these projects. But if you found a way to improve your design and construction practice to mitigate the things that have been going wrong on projects, there's quite a bit of potential performance gain. I mean, this is, again, just a lot of room to still always do better, and performance studies like this are a big part of that. And this was kind of one of the things that we put together to show, this is why we like to do this, or why it's worthwhile to do this, is because there's still a lot we can improve, especially with a relatively new technology like concrete overlays, that we still stand to be able to gain a lot from this. So with that, again, these performance studies have been very helpful for us to understand and improve design and construction processes. We've been able to see that in a lot of different environments, a lot of different traffic volumes, design situations and things like that, that we've been able to successfully design concrete overlays to achieve and even exceed their intended service life. And, still lots of things we're hoping to learn, but with kind of continued growth of concrete overlay construction, again, we should be able to get even better and better data. I know in Iowa, we'd like to, keep updating our data set and do follow-up studies, and maybe even find some other ways to look at the data. And with all that, I think overlays are really poised to continue, the maturation into, again, just a regular part of the pavement network tool in the toolbox for pavement engineers. So with that, thanks everyone for sticking around. I know especially it's getting late on the East Coast, but thanks again for being here today, and would be happy to answer any questions.
Thanks very much, Dan. There were 3 questions for you. First one is, Iowa is the leader in concrete pavement overlays. Most applications seem to be on rural roads. Are they using overlays on the interstate, and if not, why not?
We do have some thicker unbonded overlays on like divided highways, and a few on the interstate as well. It's actually not as much a matter of, it's not so much that we're not using them on the interstate here. We do have projects that come up. Iowa DOT probably builds on average 1 or 2 concrete overlays every year in various contexts, but it's just more that the county market is so much larger for concrete overlays that it ends up being 90% of the data set. So we have used them in just about all of different design contexts, but that's kind of, that just ends up being that we have, 1 million square yards of county highways every year. And so that ends up being the main market. There are a lot more low volume roads out there, if you're tallying up just miles of pavements. So.
Great, thanks. And the only other question was, for a 30-year expected lifetime, what is the recommended unbonded concrete overlay thickness range?
So that's going to be dependent, again, on all your traffic inputs, probably mostly traffic related. I know to get the 30-year pavements in Iowa on those low volume rural roads tend to be 6 inches thick. But then if you're going to go into, a divided highway type of context, it's going to be, I know the unbonded overlays here in Iowa that I'm familiar with tend to at least be 8 or 9 inches thick. And I know that there are some that are built even, I'm trying to think those Illinois projects, since I was just looking at the paper from Illinois for unbonded overlays on the interstate, as I was putting this presentation together. I want to say a lot of those tend to be 9, and there might even be some that are 10. So, it depends what type of design methodology you're using, obviously, as your inputs. I know I think it was a project led by the University of Minnesota, or maybe MnDOT. It was probably done by the University of Pittsburgh, but it was through MnDOT. I think they just finished a brand new design procedure for unbonded concrete overlays. So that would be something maybe to check out if you're interested in seeing, for your input values, what might you use there.
Good, thank you.